Hi guys, are you ready? Let's complete chapter 9 tutorial, okay? So let's discuss question 6 until then. Any problem you may ask me, okay? Physics is so simple, don't worry. Okay guys, question number 6. There is an object, the mass is 60 kilograms, connected to a spring with a force constant of 45 Newton per meters that oscillates on a horizontal frictionless surface. Horizontal, okay, means that the displacement just on x component lah. Alright, and then the amplitude given is 5 centimeter. They ask you to calculate the total energy, the kinetic energy and the potential energy at displacement of 4 centimeter, and then they ask you to sketch a graph of kinetic energy against displacement, also the potential energy against displacement. Right, so based on the info given just now, they ask you to calculate, okay, these three things. Okay, how is it? So first, total energy equals to half m omega squared a squared. Alright, at the same time, omega equals to square root of k over m. By combining these two equations, you will get this. Alright, and then we may simplify it to be like this. And then we just substitute the value of k and a given already, okay, which is 45 and 0.05. Alright, then you will get the total energy, which is equals to 0.056 joules. Okay, settle for the first part, which is E total. Now they ask you to find the kinetic energy and the potential energy at 4 centimeter displacement. Okay, so how is it? For the kinetic energy, we just use the equation directly, which is half m omega squared a squared minus x squared. Okay, and then we just substitute all the values. Don't forget that m omega squared now still equals to k. Alright, and then a given is 0.05 and x is 0.04, then you will get the total kinetic energy at 4 centimeter displacement is 0.02 joules. Okay, again, to calculate the potential energy by using the equation of u, which is half m omega squared x squared. Okay, again, m omega squared still equals to k actually. Alright, so x is 0.04, and then you will get the total of potential energy at 4 centimeter displacement now is 0.036 joule. Okay, they ask you to sketch a graph of E against X. Alright, so remember, this is the graph. Okay, so we just focus on the equilibrium position, also on the amplitudes. So as we know, at the amplitude, the object needs to stop for a while to change back its directions to be backward. So V equal to 0, and V equal to 0, automatically K equals to 0. So at the amplitude, K equal to 0. At the equilibrium, K is maximum. So the orange curve now representing our kinetic energy. Alright, and then what happened to U? Just in opposite of K lah. Okay, so when K is 0, U is maximum. When K maximum, U is 0. Then the blue curve here representing our potential energy, and the red line here representing our total energy, where the total energy still remain conserved. Okay, at any point, U plus K giving you E total. Okay, alright, so this is the graph, okay, of energy against displacement. Next, question 7. A 100-gram mass is attached to a spring and it is set to perform simple harmonic motion, okay, with amplitude 8 centimeter and period 4.2 seconds. Calculate the spring constant, the maximum speed of the mass, and the maximum acceleration of the mass. Okay, what do we have now? The mass is given as usual in grams, so we need to convert it to be in kilogram. The amplitude given is 8 centimeter, okay, in meter is 0.08. The period given is 4.2 seconds. They ask you to find the spring constant, the maximum speed of the mass, and the maximum acceleration of the mass. Alright, so it's quite simple. So we are talking about a system involving a spring. So the equation of period for any spring system is 2 pi square root of m over k. So by rearranging the equations, you will get this and this. So we just substitute all the values given. Mass given is 0.100 kilogram, and the period given already, which is 4.2, okay, giving you the answer, which is 0.22 Newton per meter. Okay. Alright, and then B, calculate the maximum velocity or maximum speed. So maximum speed equals to A omega. How do you get it? From the equation before, the basic equation before, which is y equal to A sin omega t. For the first differentiation, giving you V, which is dy over dt, which is A omega cos omega t. So V is maximum when the cosinus function here is maximum to, which is equals to 1. So giving you A omega. So A omega equals to 2 pi over period. Then we just substitute all the values given. There you get the answer, which is maximum speed is 0.12 meter per second. Okay, and C, they ask you to find the maximum acceleration, still the same as before. Alright, so V equals to A omega cos omega t. For the second differentiation, which is dV over dt, giving you A, so you will get A omega squared sin omega t, negative represented direction, right? Remember. So A is maximum when the cosinus function here is maximum 2, which is equals to 1. So that you will get A max equals to negative A omega squared. Alright, so by using this equation, again omega equals to 2 pi over period, and then we just substitute all the values given, then you will get the answer. Don't forget the unit is meter per second squared. Okay. Okay, next question number 8. A graph is given here, which is U against X graph. So from the graph, what do we have? Alright, so the amplitude is given here, which is equals to 0.2 meters. Alright, and then the maximum potential energy also given, which is equals to 1.0 joules. And the mass of the object for this case is 4 kilogram. Okay, so they ask you to find the period of the oscillation. Alright, so according to the equation of potential energy, which is half kx squared. So remember, k equals to m omega squared. Alright, so U maximum potential energy given is 1.0. Alright, and then m given is 4. Omega, okay, we need to find it, leave it first. X given is 0.2. So from this you will get omega, where omega equals to 2 pi over period. So that you will get the period, which is equals to 1.78 second. Okay, it's quite easy for question number 8. Okay, next question number 9. An object of mass 100 kilograms suspended from a light helix spring is in a simple harmonic motion with period of 1 second. What additional mass should be added to the spring so that the spring will oscillate with a period of 3 seconds? Alright, so what do we have now for question number 9? The mass is given, the original mass given is 100 kilogram, so that the period of the system is 1 second. And now the period changed to be 3 seconds. So they ask you to find the additional mass needed here, okay, for this change. Alright, so according to the equation of period equals to 2 pi square root of m over k. So from this, for the same object, what do I mean? Constant mass, T and, okay, again, T equals to 2 pi square root of m over k. So in this case, we are using the same spring. So k is constant. Alright, but now we are talking about the changes of period caused by the mass. Okay, so what is the relationship between T and mass? They are directly proportional, where T and square root of mass, now they are directly proportional. Okay, that is why for this case, they ask you to find the additional mass needed here to change the period from 1 to be 3 seconds. Okay, we are using the same spring, so K still the same lah. Okay, so as we know, T and square root of m, they are directly proportional. So by having two different situations, which is T1 and T2 here, so the question is take out a ratio and between the second situation and the first situation. So T2 equals to square root of M2 divided by T1 equals to square root of M1. Alright, so M1 is the original mass before. M2 is the new mass, which is original mass before M1 plus the additional mass there, which is M prime. Okay, so T1 and T2 given already, M1 given also, which is 100 kilogram, M1, then you will get the additional mass needed here to change the period from 1 to be 3 seconds, which is equals to 800 kilograms. Okay, we are using a ratio method. All right, so this is the way. Normally, by giving you two different situations, we just take out the first equation, the second equation for these two different situations, and then by having ratio between these two equations, then you will get the answer. Okay. Okay, next, the last question, which is number 10. The time taken for a simple pendulum to travel from equilibrium position to its highest point is 1.5 seconds. Alright, determine the period of oscillation, the length of the pendulum. Alright, so we need to know what value is given here, which is 1.5 seconds. Okay, the keyword is travel from equilibrium position to its highest point, from equilibrium to amplitude. Okay, what is that? All right, so for this, as we know, from equilibrium to amplitude is quarter of one complete oscillation, which is T over 4. Because remember, for one complete oscillation, there must be 4 different quarters in it. From equilibrium to amplitude, amplitude turns back to the equilibrium, equilibrium to negative amplitude, then negative amplitude turns back to the equilibrium. Okay, so for this, from equilibrium to amplitude, just one of it, that one is quarter of period. Okay, so they ask you to calculate the period, also the length of the string. Alright, so in this case, okay, 1.5 second given equals to quarter period, then you will get the period lah. Alright, and then for the pendulum, the equation of period is 2 pi square root of L over G. Alright, period given, or period calculated just now, which is 6 seconds. Okay, L we need to find it, G just a constant. Substitute into this equation and then you will get the answer. So the length of the string for this pendulum is 8.95 meters. Okay, alright, complete already tutorial chapter